This is lesson 512, selecting a trig tool. So in all these problems, this is just a lesson full of problems for the most part. We're just going to be selecting whether we're going to use sine, cosine, or tangent, and then we will solve for x. So first things first, I'm going to write out my SOHCAHTOA from last time. SOHCAHTOA. And if you didn't watch the last video, this simply means S for sine, C for cosine, T for tangent, and the O, A, and H's are the opposite, adjacent, and hypotenuse sides. So this just tells us what our ratios should be. So with 28 here, we have the opposite and hypotenuse. So that is going to be sine of 28 is equal to x over 19. That's the opposite and the hypotenuse there. I'm going to set all these up and then come back and solve for x. Here we have the opposite and adjacent. So this is going to be tangent of 45 equals opposite over adjacent. Here we have hypotenuse and adjacent. So that's cosine of 61 is 18 over x. And then over here, we have the opposite and the hypotenuse, so that's sine of 25 equals 6 over x, opposite over hypotenuse. Here we have the adjacent and the hypotenuse, so that's cosine. And that's going to be 8 over x. Here we have opposite and hypotenuse, so sine of 30 equals the opposite, x over 42. Down here, now 0 degrees, we cannot have a 0-degree angle in a triangle. That's not possible. Over here, 73 degrees, we have the adjacent and the hypotenuse side, so that's cosine of 73 equals x over 3. And then over here we have the opposite and the adjacent, so that's going to be the tangent of 42, opposite over adjacent, so x over 12. Now coming back to solve these, I'm going to be cross multiplying here. So x equals the sine of 28 times 19. Now, quick side note, what you should be typing into your calculator is sine of 28, closing those parentheses, and then multiplying by 19. Because if you are doing the sine of 28 times 19, that's something completely different. We don't want that. We want this. So just to show you what I'm typing into my calculator, x equals 8.92. Over here we are cross multiplying. The tangent of 45 is 1, so that's 1x equals 8, so x equals 8. Cross multiplying here, the cosine of 61 is 0.48. So we're going to divide both sides by 0.48. So x is 37.13. Here we're cross multiplying. The sine of 25 is 0.42. And that's equal to 6. So I'm going to divide 6 by 0.42. So x is 14.2. Now, depending on where you're rounding in this process, you may get a slightly different answer than me, and that's okay. Here, cross multiplying, the cosine of 60 is 0.5. So I'm going to divide 8 by 0.5, and x is 16. Here, cross multiplying, the sine of 30 times 42 is 21. So that's what x is. Not possible down here. Cross multiplying down here. the cosine of 73 times 3 is 0.88. And then tangent of 42 times 12 is 10.8. Okay. Moving on, stolen calculator problems. Someone stole your teammate's calculator. She has to take her geometry test now, and she was asked to find the length of x in the triangle to the right. The answer she came up with is called an exact answer, okay? So she set up the ratio. She knew she was using sine, which is opposite over hypotenuse. So she said sine of 25 is equal to the opposite over the hypotenuse. When she cross-multiplied, she got x times the sine of 25 equals 29, and then divided both sides by the sine of 25. And because she didn't type this into her calculator, that is why it's an exact answer, because she was not rounding. Your calculator rounds this number for you, and then sometimes you round the number when you're asked to. Okay, so we're going to use our calculator to find that approximate answer. So I'm going to type in 29 divided by the sine of 25, and that gets me 68.62. And again, I'm rounding that. So apparently we solved the problem differently, but still got the same answer. We started with the equation cosine of 65 equals 29 over x. Well, if we redrew this triangle, this missing angle here is 65 in order to get us 90 degrees. So if we use that angle instead, this is now our adjacent and this is our hypotenuse. So adjacent and hypotenuse, which means we're using cosine instead of sine. So the cosine of 65 is 29 over x, right? That's what we had. And of course that would get us the same thing because it's the same triangle. We're working with the same triangle here, so we should get the same answer for x. So if you have both angles available to you, you kind of get to choose which angle you want to base this off. So we're going to solve for y here, do this two different ways. All right, so we could start with the 53. I'm going to color code this. So this is the opposite side and the hypotenuse. So the cosine, or I'm sorry, this would be sine of 53 would be y over 5. And then if we cross multiply those, y equals 3.99. And then let's say instead we want to do this angle right here, and that angle would be 37, right? Because all the angles should add up to 180. And now, because we're focusing on this angle, this is now the adjacent side, and this is still the hypotenuse. So now we're using cosine because we're working with the adjacent and the hypotenuse. So the cosine of 37 is y over 5. And let's cross multiply this. And would you look at that? We still get 3.99. So we solved that in two different ways. So we're going to use our trig table toolkit to determine the missing angles. Okay, 9 over 9. That was a ratio of 1 over 1. I remember that's a 45-degree angle. 1 over 5, I remember that was an 11-degree angle. And then our 5, oh, we have to reorient this triangle, don't we? Okay, we don't have the change in y here, but we could find it by doing Pythagorean theorem. 5 squared plus x squared equals 10 squared. So x squared equals 75. So our missing side is 8.6. So change in y over change in x, 8.6 divided by 5. That's 1.72. And I'm going to have to look at our toolkit to remember what we got that was close to 1.72. think the closest we have is about a 55-degree angle. So that is about what that would be, 55 degrees.